This is chapter 2, page 14. What might make this problem a little better, it's not a word problem. You don't have to interpret it. We just have to graph this. So this is x. I'm going to go 0 all the way up to 5. And here's y. So if we graph each of these, we're going to just shade the region. We're going to find the polygonal convex set, which is common to all three of these. X is greater than or equal to 0. X equals 0 is a horizontal line. And right now, we would shade above. I'll graph this lightly. The second constraint is y is greater than or equal to 0. So if I graph this, and it's greater, that means we're now in quadrant 1. So right now, we got to focus on this. And then the last one, if I made a quick XY table, 0, 5, 5, 0 are ordered pairs. And because it says less than or equal to 5, that means like 1, 1 would work. So here's the region. And if it says name the coordinates of the polygonal convex set, we just want these three vertices. So that would be 0, 0, 0, 5, and 5, 0. That would be our answer for 2. Vertex theorem. And this will apply to the next problem. The maximum or minimum value of a function in this form, ax plus by plus c, on a polygon convex set will always occur at a vertex of the polygonal boundary. So we're going to do the same concept as we did in example 2 for this problem. This is example 3. But the difference here is once we come up with our vertices, we're going to plug them all into this function. So I'm going to go by 2's here. And I know that because the intercepts here would be 7, 0, and 0, 14. And if I don't go by 2's, I'm going to be off my numbers will be off the graph paper. So I'm going to do it like this and like this. I'm going to graph all the regions and then figure out where my polygonal convex set is. So x is greater than or equal to 1. Horizontal line right here. And I'm shading above. So I'm going to just shade this lightly. Next one, y is less than or equal to 8. So y is a vertical line. So it's like this. And so it's, right now we're to the left of this line, but above x equals 1. And then here I find the intercepts. So that is 7, 0, and 0, 14. It looks like this. And then if you don't know where to shade, just plug in an ordered pair. So if I plug in 1, 1, 2 plus 1 is less than or equal to 14, which is true. So right now, from all the values, we would shade below here. So right now, we have this triangular region. But there's more. Y is greater than or equal to 2 is a horizontal, or scratch that. I was graphing x equals 2. Y is greater than or equal to 2 is a vertical line. Okay, hang on. 1, 1. Here, x equals 1. I did this backwards. Scratch. Okay, hang on. Let's take 2. Okay, 0s, 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14. X equals is a vertical line. I mixed this up. So x is greater than or equal to 1 is this vertical line. And right now I shade to the right. Next, Y is less than or equal to 8. That's a horizontal line. And it's below it. So right now it's below here. Here, the intercepts were 7, 0, and 0, 14. And it's less than or equal to. So like 4, 4 would work. So right now it's everything under here. Then it says Y is greater than or equal to 2. That's a horizontal line. So right now, here's the region, this like trapezoidal region. And then if we graph the last one, the intercepts are 0, 5, and 5, 0. It will look like this. But it's greater than or equal to 5. So if I plugged in like for instance, 4, 4 would work. So it should be this region right in here that's common to all of them. So we need to name the vertices and then plug in. So in this case, we got to name the vertices. So the vertices here would be this. This point right here is 6, 2. Here, when Y is 2, X is 3. Here, this is on X equals 1. And the value that would make this true if X plus Y equals 5, this is 1, 4. And then both of these points, the Y value is 8, as we could see. Here, this is 1, 8. And if we want the other one, we know it's 8. And if we're not sure on X, we would just plug into this equation. 2X plus 8 equals 14. If we solve, we get X equals 3. So what we need to do now is take this function and plug in all the ordered pairs. So we've got 1, 4. We've got 3, 2. We've got 6, 2. 1, 8, and 3, 8. And we're going to plug them all in. And we want the biggest and smallest value. So here, if Y is 4 and X is 1, I get 7. Here would be 1. Then I get -5. Then 8 minus 2 times 1 plus 5 is 11. And then last one, I get 9. Or 13 minus 6, let's call it 7. Okay, so we want the biggest and smallest value. Out of all 5 of these, this is the maximum value, 7 or 11, and -5 is the min value. So the idea here is we graph the polygonal convex region, which is this 5-sided figure, and then we plugged them all into this function, and the biggest value we got is 11, smallest value is -5. This is example 3 from page 14 from chapter 2.